Hi, I'm course by 11.5 from YUMIN Primary School. This lesson is Techniques of Definite Integral and its Applications. So right now we have method number 3, which is the reduction. We already have two methods. First method is the symmetric property of the integrand. And the second method is, well, we just find another integrand. When you integrate, we have the same answer and actually related. Well, I can call these corresponding integrand or related integrand, but actually it doesn't have a definite name. So right now we're at method 3, which is the reduction. So for this reduction, first we'll find a formula for this, which is the integral from 0 to half pi, and this is sine to the power of nx dx. So for this, how should we find a formula? Well, we can use integral by parts. So we can separate it into like this. Well, you might ask me, why? Why should we separate it into like this? Let me just tell you, for that, the sine x, we can put it inside the dx, which will become a cosine x. And remember, when you put it inside as a cosine x, there will need to be a negative. So for this, we can right now use the integral by parts. So remember, for this integral by parts, at first here was a minus because of the negative, so it becomes a plus. Like this, and then remember, when you sub in the pi over 2 for this cosine, it will be 0, and when you sub in 0 for the sine, it will also become a 0. So for this, there will be no more. Then at this part, the sine, we can move it out. Which, remember, it will differentiate. So for this, which will actually have like this. Then for the cosine square x, we can use the 1, which is equal to sine square x plus cosine square x. And then we can separate. So next, for this, we actually have the minus this thing. Which is like this. So this part, remember, the integral half pi sine to the power of nx dx. We also have it in this place. This is a negative. We can move it to the other side. So remember, negative becomes a positive. So that will become an n. So we can write this as in. Then this will be the in minus 2. So for this to find the in, this will actually be, so divide the n to the other side. Like this. And then after that, so this is actually like this, divide the n. Like this. Okay, so this is actually how we get that formula. So remember, when we have this to the power of whatever, we'll just need to have this and then minus 2 from the power. So from this part, well, we can try out 2 of the examples, which is to the power of 18 and to the power of 17. So I'll draw one example over here. So for this, n, remember it's a power, so n minus 1 over n, 17 over 18. Then remember, at this place, 18 minus a 2 will be 16. So 16, you'll have 15 over 16. Then after that, you just keep continuing. So actually, at last, what you have is here half. Okay, and remember for this, if the power is a 0, it means that this part is a 1. So if this part is a 1, it will actually be an integral from 0 to half pi dx. So here we'll have an extra half pi. So for this, 17, 15, 13, 11, we can write it as the 17 factorial. And then at this part, 18 factorial. But remember 18, well, actually we can have a 2 out of each of these. Or it's actually write it as a 9 factorial. So here we have 2 to the power of 9. And then after that. But remember this 17, 16 is missing, 12 is missing. Actually here's a 12 and here 14 is missing. So we'll need another, remember 16 when divided by 2 is actually 8 factorial. And you also need 8 more of the 2's. But you have like this, and don't forget about that half pi. So for this, let me just write them all together. Remember, this is 9, 8, and 1. So we can write it as 18. Like this. This is our answer. Or, remember, this is actually the best way of representing our answer. For another way, we can write it like this. But this is not so good because, well, some places they don't recognize this way of writing, but like everyone recognizes this way, so that is why this is the best way of writing it. So this is just only one of that example. So we can have the next example. I'll write it over here. This is integrate from 0 to half pi sine to the power of 17x dx. So at this part, actually we can just move. Well, we don't really need to move as we just straight away use this formula. So for this, remember this is 17, so here 16 over 17. Remember, it just keeps going on until you cannot have it anymore. So remember at 2 over 3, this 2 over 3, well, you're just left with sine x. Sine x, well, we can put inside the dx, which will have a negative. Then after that, remember cosine x, and here is pi over 2 first, 0. Cosine x, 0. At that time, it will be a negative. So here we'll times a negative 1. Negative and negative can actually cancel out. So for this, remember for this 17 factorial, here we can divide it by, well, actually for this 16 we can just write it as 8 factorial again. 8 factorial, but how many numbers? So 8 numbers, so it's 2 to the power of 8. Then after that, at this part below, we missed out 16, 14, 12. Well, here we actually have 10. And then remember, we also have the 2 that is also missed out. Okay, so what we'll have is like this, and then we can combine those things. So we actually can have it like this. And then after that, remember this actually, what we can write it as, another way of writing, which is something like that. It's actually like this. Well, because that, oh wait. Okay, so is it like this? Remember, this is actually the best way of writing it. So you'll see from here, well, these two examples are just trying out this formula, which is actually what we get from this, right? Then in the next lesson, we can use other methods to find out what is the answer for this, to check that it is right. Or you can also use the calculator to check. But remember, actually calculators, they don't know what is this. Okay, so you should use this and this. Okay, so far for this lesson, we have talked about this. Well, reduction. We first have this question, then at last we have like a formula. Then actually we can just put it into these examples to try. Okay. So remember these examples, we can just call it exemplification. So far are you all clear of this? Okay, so I can end this lesson over here. So if you like our videos, don't forget to subscribe to our channel. Thank you for your watching.